Okay, we're going to go to the next part of chapter 15. We just finished part one. I'm going to dismiss my image and we're going to talk about heat. Um, and we commonly think of things having heat or a lack of heat. And that's not the term, that's not how we use heat in the physics sense. Heat is internal energy transferred from one thing to another due to a temperature difference. So it's internal energy in transit. Um, it's it's similar to uh, the term work. You don't talk about an object having uh, an amount of work. Uh, if it has potential energy, when you let it go, it does work. It performs work. When you um, push a box across a floor, you are doing work. But the box itself contains no work. So you can think of it in that sense. Heat is the transfer of the high kinetic energy of one object to transferring to an object that has lower kinetic energy. So it's the flow of internal energy from a high temperature substance to a low temperature substance until thermal equilibrium is reached. And so it always flows from high temperature to low temperature. Internal energy never flows unassisted from a low temperature substance to a high temperature substance. Um, so it's always from high temperature to low temperature. You put a piece uh, if you put ice cubes into a hot cup of tea, the hot tea is transferring to the ice cubes. The ice cubes aren't cooling off the tea. The hot tea is transferring to the ice cubes and melting um, the ice. Okay, so you always go from a high temperature to a low temperature. Um, so if a red hot thumbtack is immersed in warm water, the direction of heat flow will be from the warm water to the red hot thumbtack, the red hot thumbtack to the warm water. There will be no heat flow, so there's not enough information. Well, in this case, from what we just learned, it always goes from the uh, the higher temperature to the lower temperature. So the red hot thumbtack is transferring heat to the warm water. Oh, a quantity of heat is measured in joules or calories. Now you're going to have to pay attention to the lowercase and uppercase c in the word calories here, and we'll see that in a little bit. There's 4.18 joules of heat. 4.18 joules of heat are required to change the temperature of 1 gram of water by 1 degree Celsius. And 4.18 joules equals 1 calorie. 1 calorie. Now, that's not the calorie that is listed on the back of the food that you eat. You know, something may have 270 calories. Well, it's not just this calorie. Um, that is a kilocalorie. We'll read about that on this slide. Energy ratings of foods and fuels are determined from the energy release when they are burned. The unit of energy, the calorie, notice the uppercase C, the calorie is common for foods. The heat unit for labeling food is a kilocalorie or 1,000 calories called a calorie. Notice the uppercase C as opposed to the lowercase c in like right here, the uh, lowercase c for 1,000 calories to one uppercase C calorie. It's the heat needed to change the temperature of 1 kilogram of water by 1 degree C. A calorie is just raises a gram of water. Well, 1 kilogram is 1,000 grams of water. So it takes 1,000 calories or 1 kilocalorie to raise 1 kilogram of water by 1 degree. Okay, the same quantity of heat is added to different amounts of water in two equal sized containers. The temperature of the smaller amount of water decreases more, increases more, does not change, or there's not enough information. Okay, if it contains a smaller amount of water, it's going to increase more. Um, it's gonna rise more rapidly when heat is added to it. Um, okay, you heat a half cup of tea, and its temperature rises by 4 degrees C. How much will the temperature rise if you add the same amount of heat to a full cup of tea? Well, if a half a cup of tea only raises it rises by 4 degrees, the full cup will go half as much. So it's going to go 2 degrees. And there you go, 2 degrees. And that's the end of part two. So it's a short little section. So we'll end this. Let's stop the recording.